Well then guys, we go through the process. Now we are at the end. Question 40 of paper 1. Okay, you did a great job. Okay, we go through it together. Well done. So now question 40 is about electron diffraction. Okay, and then it's talk about there's a minimum value, and they want to compare the same speed but to a nuclei of double the diameter. So what will happen to the nuclear density and feeder? So remember, what's nuclear density? It is the mass per volume of the nucleus. You remember, although the nucleus doubles, the size doubles, but all the nucleus, neutron and proton are closely packed. So the density of proton and neutron inside the nucleus are very similar. Nearly the same for different nuclei. So this nuclear density, we can take it as the same, nearly the same. Just a little bit variation. The other one is about the angle theta, minimum angle. How does it being affected by the size, the radius of the nuclei? So you have to look it up for the equation. You got it. Take the bullet. Which one? Yes, sine theta equals lambda over d. D is the diameter of the nuclei. Now d doubles. How about lambda? Lambda is the wavelength of the momentum of the electron, and you have to look it up for the equation again. De Broglie wavelength equals h over p. Yes, same speed, same momentum, so same lambda, so low change over d. D is double, so the whole fraction drops. And as sine theta increases with theta, so this also drops the angles. So theta minimum should decrease. So which one is the answer? Yes, you got it. The answer is A. Thank you. It's a really a big release for me, okay? So we'll try to move on to paper 2 and paper 3, okay? Are you ready for our next journey? See you